Hello everybody, so today I will talk about calculus. The topic today is about integration. So now I will show you the technique how to answer. This one we need to use about integration by parts. So we have u equal to s, du equal to ds, dv equal to e to the power of negative s ds. So we got about v equal to negative e to the power of negative s. So we have u multiplied with v. We have negative, so you got about positive. So this one you got about negative e to the power of negative s, and we have the powers in here. So for this one we got about negative s over e to the power of s, and we have the positive line in here. We go negative with negative, that's why you got a positive. This one we know this is about go to 0, go to 0. But this one we know that s go to positive infinity, this one still go to positive infinity. Similar, this one go to negative infinity. So this one with this one you got about negative infinity. So we can say this is about divergent. Now let's go to the next one. We multiply with s on numerator and denominator. So we can use about substitution. So we put about u equal for the square root. So we put the square in the both sides. So we put negative 4 in here. We do first the derivative in the both sides. Number two, they simplify. Now we need to change the powers. If s equal to number 2, so you got about 0 for u. If s equal to number 4, we put number 4 in here. And you got about the square root of number 12. So this one we change for u. 2s ds, we change for 2u du. S square we change for this one, u square plus 4. So we got about 2, and we have the integral from 0 to the square root of number 12, and you got about du over u square plus 4. So you got about 2 over 2 r times of u over 2, and we have the powers in here. So this one is you got number 1. So you got about r times of the square root of number 12 over 2. So this one you got about b over 3. Now let's go to the next one. About sine x, we can go about negative cosine x, and we have the powers in here. We put the limit of s go to positive infinity, negative cosine x. This one you got about positive cosine of negative number 2. This one is diverge. Why? Because when s go to positive infinity, the value they go up, go down many times like this. So this one is divergent. The next one, we put number 3 in here. This one we can put a minus s to the power of negative 1 over 2 ds. So we can get the final answer. Negative 1 over 2 plus 1, you got about 1 over 2 in here. This way you got about 1 over 2. And we have the negative in here because we have negative s. We put the bounds in here. If we put number 8, you got about 0. If we put 0 in here, you got about negative 3 square root of number 8, and we have 1 over 2. Because we have negative, so you got about positive. This one, you got about 3 multiplied with 2 square root number 2 and another number 2. So we got about 12 multiplied with the square root of number 2. Next one, we multiply with e to the power of s on numerator and denominator. So you put this one in here and here. You got about e to the power of 2s plus 1. So we can use about substitution. So we can change the bounds. So we put about u s equal to 0. So u should be about number 1. S equal to positive infinity. So u should be about positive infinity. So on the top we change for du. This one you got about u square plus 1, and we can put about all time of u, and we have infinity and number 1. So we have the limit. And this one all time of number 1, you got about b over 4, and this one you will got about b over 2, and this is about b over 4. Now let's go to the next one. So in this situation we need to use about s equal to 4 secant of t. The s we change for 4 secant of t tan t dt. We change the bounds if s equal to number 4, so t should be about number 1. If s equal to positive infinity, so t should be about b over 2. This is should be number 0. So we change the bounds in here. So we put about 4 secant of t in here, you got about 16 secant of t squared minus 16 over, we put this one in here, the square root of number 16 is about 4. 4 with 4 is about 16. Now we cancel number 16 in here. This one we change for tan t squared. Square root of tan t squared, you got about tan t. And now we simplify. We simplify with secant of t in here, from here with here. Now we got about tan t squared in here. About this one, we can change about secant of t squared minus 1 and we got about secant of t minus cosine t. This one we got about ln of the absolute value of secant of t tan t, and this one we got about sine t, and we have the bounds in here. Now I will consider about the limit inside this one. for this one, we can put about this one is about 1 over cosine t. This one is sine t plus cosine t, and so I put the same in here. If we put b over 2 in here, we got about 0. This is about number 2. So in this situation, we got about 2 divided by 0. So that means you got about positive infinity. If you got about the positive infinity in here, this is about divergence. Now let's go to the next one. If we put about f of y equal to y over y squared plus 1 to the power of 3. If we put about f of negative y in here, we got about negative y in here, but we got about y squared in here, so you keep about y squared plus 1 to the power of 3. So this is about negative f of y. So that's about of function. Because they have the powers in here, we have infinity, negative infinity, but we have odd function. So that means you got about 0 in here. Next one. We can use about substitution. So you got about du equal to ds over s. Next, we need to change the powers. If s equal to number 1, so u should be about number 0. If s equal to positive infinity, so u should be about positive infinity. So we got about from 1 to positive infinity. lnx we change for u. ds over s we change for du. So you got about ln of the absolute value of u. This one we got about limit, and u will go to positive infinity, ln of u. This one you got minus number 1. We can see that this one they go to the positive infinity, so we can say that's about divergence. That's the end. Thank you for watching.